Hello everybody. Today we're going to talk about the improper integral. In this video, we will mainly go through this specific problem, and when solving it, we will review some of the key points related to the question in this chapter. So let's first look at the question first. Find the value of the constant c for which the integral converges. The integral is 1 over the square root of x squared plus 4 minus c over x plus 2 from 0 to infinity, and evaluate the integral for this value of c. In this question, we have two things to do. The first one is find the value of the c, and the second one is find the value of the integral using the value of c. So let's look at the integral first. We clearly see that there is an infinity at the upper bound of the integral, which fits our criteria of our type 1 of the improper integral. Let's look at this definition first, which says we have an integral from a to infinity, and we integrate it of the function of f of x, and we need to rewrite it as the limit t approaches to infinity from a to t of the function f of x, if the integral exists for every number t larger or equal to a. And so then we need to think about the convergency. And in general, we say if the limit exists, the integral converges. Let's look at back of our question. So we need to rewrite it first as the limit. Take the limit t equals to infinity and the integral from 0 to t, and we copy the terms here, and which is 1 over x squared plus 4 minus c over x plus 2 dx. And then there are two terms in this of this integral. Here is the first one, here is the second, and it's clear that the second one is more easy for us to do the calculation. So we concentrate on the first term here, and we first think about the indefinite integral of this term, because it is more easy for us. And let's say the integral of 1 over x squared plus 4 dx. And we see that we have a square root and in which is x squared plus an coefficient. So we think about the trigonometric substitution here. Let's say x equals to 2 tangent theta, and dx equals to 2 secant square theta d theta. So we can make it the square root, cancel the square root after calculation. So let's see. We can rewrite this integral as 1 over 2 secant theta. When put 2 tangent theta as the place of x, we got 2 secant theta. So there is no square root now, which is much better. And times dx equals to 2 secant square theta d theta. Let's copy down here. Right, and we cancel out the 2 and one term of the secant theta. We got the integral of secant theta d theta. So when looking at this integral, it is we need to do some calculation, absolutely. So, but I will go through it quickly because it is not the main part of this question. So here we look at this one. So the integral of the secant theta is actually the integral of 1 over cosine theta. And in order to integrate about the cosine, we need to find some terms of sines. So we multiply both numerator and denominator with cosine theta, and then we can make it more clear. And we got cosine theta over 1 minus sine squared theta. And then when we further work on it, we can have this term now. So now we can think about the partial fraction to solve this problem. And we first use an u substitution to make it the integral more simpler, and we got the integral of 1 over 1 plus u times 1 minus u du. And after using the partial fraction, I will skip this part, and we got the two integral. And when integrate it, we will get 1 over 2 log the absolute value 1 plus u minus 1 over 2 log the absolute value 1 minus u plus c. And we do further work on it because the logarithm can simplify it, and we make it as 1 over 2 log 1 plus u. There is an absolute value, and divided by y minus u plus c. And then we need to substitute u with the original sine theta here. So we got this one. But we are not finished, because we need to think back to our original substitution, which is related to tangent theta. So we need to do some more work to make this term related to the original one. So we times both numerator and denominator with 1 plus sine theta here. Then we will get this one. This is the after expansion of the 1 plus sine theta square, and this is after the simplification of the 1 minus sine square theta, right? So now we have this term, and we can now divide each term inside the absolute value, and we will get 1 over 2 log absolute value of secant square theta plus 2 times tangent theta, secant theta. There is theta actually, and plus tangent square theta and plus c. And inside the absolute value, it is actually the secant theta plus tangent theta square, the sum of it, the square of sum of the secant theta and tangent theta. And we can take the power of 2 out of the logarithm, and we got log secant theta plus tangent theta and plus a c, right? So we write here log absolute value of secant theta plus tangent theta plus c, right? But we are not finished. We need to replace the theta with the x of the original substitution. So we solve for the theta. So x over 2, we take this here. X over 2 equals to tangent theta. And we need to use the formula tangent square theta plus 1 equals to secant square theta to solve for secant theta. And we take a square root of both sides and put x over 2 to the place of tangent theta. We will get the square root of 4, let's see, right, 4x squared over 4 plus 1, and which is, let's write here, the log. The secant theta, we can write it as square root 4x squared over 4 plus 1, and plus and tangent theta, which is x over 2, absolute value, plus c. And we can simplify this term, and we take 1 over 2 of both terms, and we will get 1 over 2 log 1 over 2 times absolute value 4 plus x squared plus x here, and plus and c. And also we can take this as log 1 over 2 plus log the absolute value of the square root of 4 plus x squared plus x plus and c. And we can see that this is a constant now, so we took it into the c. We will get log absolute value 4 plus x squared plus x plus c. That's the final answer of our original integral of the first term. So let's come back to the original limit, which is limit t approaches to infinity, and the integral from 0 to t. And we write it as we need to write this way, log, because we already finished the integration. So it is log x squared plus 4 plus x, right? This is our first term. And the second term, which is clear that it is minus c times log the absolute value x plus 2. And we calculate from 0 to t. Now we need to find the limits of this term. So let's see, we can put 0 and t into the limit, and we will get this one. No. It is log t plus 4 plus t squared minus c times log t plus 2 minus log 2 minus c times log 2. And we calculate the limits at the end. And then we can find this one is actually a finite number if c is not infinity. So in order to have the all over integral converges, we need to have the first two terms, the limit of the first two terms as a finite number, right? So we concentrate on the first two terms, and we write it as log. We took the log outside and put the limit inside, and rewrite the log as this way. We put the c to the power, the place of the power here. We can do this because given that log is a continuous, the function of log is continuous at the point of this limit. So we will talk about it later. And then log, we can also take the absolute value, the function of absolute value out of the limit as well, because it is continuous always. Now we have this one. And then from here, and we need to do more work to figure out. So we can divide it both numerator and denominator with t plus 2. Let's write here. So then we got log limit t to the infinity, well, which is t plus 2, t over t plus 2 plus t plus 2. Let's take the square root here. And t plus 2 to the power of c minus 1. There is the absolute value. It is really complicated, but we can simplify it through our work. And let's see. Well, we can also, I will write it quickly because it really takes time to think about how to solve these complicated terms. Well, let's see. If you want to to calculate by yourself, you can pause the video to think a little bit, but I will just write it down because we need to hurry up. And let's see this one, which is limit t to the infinity, and copy down. And this is, and we expand the inside of the square root, which we got t squared plus 4t plus 4 minus 4t. And the denominator is t squared plus 4t plus 4. And then we simplify it, and we got 1 plus 2 over t plus the square root 1 minus t over 4 plus 1 plus 1 over t, and the denominator, the absolute value. And we can take the limits of both the denominator and numerator if both limits exist and the limit of the denominator is not equal to 0. So we will got the log. If we took t to the infinity to the numerator, we got 2, and we got this one at the denominator. So in order to make this one to make it converges, we need to have the numerator as a finite number. So we can see that only if c equals to 1, the limit will be a finite number, because if this is 1, the power is 0, and the whole term is 1, so the limit is always 1, and we got final answer of this log 2, the integral of log 2. And we come back to the original question. So because the second term is log 2 minus log 2, So we will get final answer of log 2 minus log 2 minus log 2. So we will get log 2.